Hey guys, welcome back. Today we're going to be talking about navigation with the compass. And one thing with navigation with the compass is magnetic declination. Now it is very, 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 very important that you get magnetic declination properly, because if you don't calculate the magnetic declination properly on your compass, you will be off by 100 feet per degree per mile. So if you're on a 10-mile hike and you're off by 10 degrees, that's 1,000 feet per mile. That's over a mile off that you would be off from your target, well over a mile. That would be 10,000 feet. You would be off by 10,000 feet, which is almost 2 miles. So you would be completely lost in the woods. Now I've seen on YouTube people doing this completely wrong. And I'll tell you, because magnetic declination is the difference of angle between magnetic north and true north. When you look at a map on a piece of paper, a map of the city, you got north, south, east, and west. But that's not magnetic north on the map. That is called true north. Magnetic north is actually a phenomenon of the Earth's magnetic field from all the minerals and stuff on the planet Earth. So there is a difference between magnetic north and true north. True north is the north you will see on the map, and magnetic north is the natural phenomenon you will use on your compass, and you can do both on the compass. And always use a lensatic compass. Those are the best compass. You want a lensatic compass. This is a lensatic compass. This is the best compass you're going to find. Lensatic compasses are the best compasses ever. Okay, so now when you open up a compass, every compass will have a spinning needle. The arrow on this compass represents north, magnetic north. And then the compass will also have a stationary line that is fixed. You cannot move it. So in order to find magnetic north, you line up the north arrow, see the north arrow, with that stationary line, and that tells you where magnetic north is. Now on a compass you will also have a rotating bezel with a few lines on them that are movable. You can change the position. And the reason for these green neon lines that you can move them is so that you can calculate declination, so you can line this up with the map. So now you pick one of these arrows, this arrow right here. This arrow right here, this neon green arrow that moves. Now, let's say the magnetic declination for the area that you're exploring is 10 degrees west. That means that magnetic north is 10 degrees west of true north. And this neon green movable line represents true north. So now, magnetic declination with a 10-degree west declination says that magnetic north will be 10 degrees west of this neon green line that represents true north. So when you calibrate your compass to the declination, you will not turn this to the left. You will not turn it west, because that would place magnetic north east of the neon green line, which would be wrong because this is a western, 10-degree western declination. So what you do is you take the neon green rotating bezel line and rotate it clockwise 10 degrees. See, now let's say this is 10 degrees. So now magnetic north is 10 degrees west or to the left on your compass of the true north. See how true north is on the east? That's because magnetic declination, this represents a 10-degree west declination, which means that magnetic north, the arrow and the fixed line, are 10 degrees west of the true north line. This is how you calibrate declination properly. And I have seen on YouTube hundreds, even major corporations, doing this wrong. And this is very, 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 very important. Those videos should be taken down because they are wrong. You will get lost. Just like how I said, if you don't calibrate your magnetic declination properly, you will be off by 100 feet per mile per degree. So if you're traveling 10 miles, you will be off by 10,000 feet if you're off by 10 degrees. Say you got a 10-degree western declination. Well, let's say you set that 10 degrees east. See, now you're off way more than 10 degrees. You're going to be off by miles. You will be completely lost. Let's say it's a 10-degree west declination and you put 20 degrees west. Now you're going to be off by 2 miles. This is very important. If you don't do this properly, you will get lost.